We have recently just looked at ionic compounds and how we go from naming to forming the chemical formula, and then we could also go from the chemical formula to the name. This example now is going to have us go, instead of ionic compounds, we're going to be looking at covalent compounds. So look at this list of names. There should be some things that you notice right away, such as we've learned that compounds will typically end up with that IDE. These all have those as well. But there's something different about them. They have prefixes. Di, mono, penta, hexa, tetra, and di. There's nothing on the front of these, but that's because we're going to learn that that is a understood mono. So whenever you put mono, if there's just one of that atom, that just means one. We're just going to ignore it. Okay, so everything else has to have it on there. If it's on the second element, you still need to put the mono on there. But if it's the first element, that name doesn't need a mono. Okay, so it's got these prefixes. So why does it have the prefixes? Well, the prefixes help us figure out that these are, in fact, all covalent. Yay! All right, so how do we know that again? Remind yourself of this. Covalent is when you have nonmetals together. All right, ionic is metal plus a nonmetal, or cation plus an anion. Covalent means nonmetals. So if you go look up every single one of these elements, hydrogen, phosphorus, lithium, chlorine, they're all above that stair step that you see on your periodic table. All right, so that's step number one. Whenever you first look at a name and you're trying to figure out what is the chemical formula for it, you have to first say, is it covalent or is it ionic? If you skip that step, you will screw up naming, or you will screw up trying to figure out what chemical formula it forms. All right, so then what do? I think covalent are a lot easier to go from the name to the chemical formula, and that is because you've got these nice pretty prefixes. So if you know what the prefixes mean, you can easily form the formula. So meaning dihydrogen, what do you think that means? It means hydrogen with, and there's two of them. Monoxide, mono, one, oxide, oxygen. So it's going to be H2O. There is one oxygen. And remember, you can put the one, but most people understand that it's a one if you don't put anything there. All right? What about this next one? Phosphorus pentachloride. Now, you might not know what penta means. And so look up at your chart and look at all those prefixes and figure out what penta means. So we start out with phosphorus, P, understood 1, chlorine, Cl, and then penta is going to be 5. So it's PCl5 is our chemical formula. What about selenium hexachloride? Selenium, find that on your periodic table, figure out what its chemical formula is, element symbol, excuse me, selenium, and then hexachloride. Okay, so hexa is 6, if we look that up. Now the remaining, dinitrogen, so nitrogen, and there's 2 of them, tetraoxide, O4, oxygen. Now you might notice this part right here. That O is in fact not a typo. That's tetroxide, okay, is how you say that. It's not tetraoxide. You don't have A and then oxide. The tetra is T-E-T-R-A, but we drop that A if the element starts with a vowel, and so tetroxide is going to be the name of it. But this is how you go from a chemical name to a chemical formula if it is covalent.